If I can now invite Ewan Vaughan to join us on the platform. Ewan comes from a farming family, from a 500-acre mixed livestock dairy, beef and sheep farm in Mid Wales. He works for Winstay Group PLC as Head of Dairy Technical Services. He's a very keen rugby player, although I'm not quite sure which he prefers, the playing or the socialising afterwards. It's not clear from my brief. His topic is sustainable protein feeding for the UK dairy industry, with a question, I think, around sustainability and profitability and whether they can come hand in hand. Ewan.
Bore da pawb. Good morning, everybody. Today, I am here to share my findings on my study topic, sustainable protein feeding for the UK dairy industry. I grew up on the family farm at Llanroedd yr Ymochrant in rural North Montgomeryshire. Here, a mixed livestock farm with 3 enterprises, so I had interest across all ruminant sectors. However, my interest in ruminant nutrition came as the first feeder wagon arrived on farm back in 2005. Here is when I decided, can we get more out of the homegrown forage we produced and increase efficiency through the way we supplemented them. Now working for Winstay Group as Head of Dairy Technical Services, I am in a position to put my passion into practice. I must also thank Winstay for their support during my scholarship. As a dairy farmer working within the feed industry, I was getting continually frustrated seeing unbalanced formulated diets on farm, diets which were far too high in crude protein, this coming at a cost to the farmer, as protein is one of the highest input costs on farm, as well as coming at a metabolic cost to the cow, affecting her health, fertility, leading to earlier culling. And as we look to the future as well, we must think how feeding high protein diets also are having a cost on the environment. Although my report is mainly based on dairy, I must admit that the topics which I bring up are relevant to all ruminant sectors. The building blocks of protein are amino acids, and each amino acid contains a nitrogen molecule. This is estimated at 16%. So we use crude protein as the figure to declare protein on farm. This is only a measure of nitrogen, and then multiplying that by 6.25. This, as its name suggests, is a very crude way of estimating protein on farm, not indicating what the protein quality is or the amino acid status. So we aren't feeding actually protein to the cow. We actually feed nitrogen. And of this, only 20 to 30% is actually converted into a saleable protein product. The other 70 to 80% is excreted, either as urine, in the urine or in the feces. This then can be lost as ammonia to the atmosphere. With the negative press associated with livestock emission over the last few weeks, we as an industry need to be proactive in reducing ammonia emissions through dairy production before legislation forces us to. Feeding lower protein diets can be a great start. Instead of feeding for crude protein, we need to look at feeding for metabolisable protein and the amino acids the cow can actually absorb. As we feed the ruminants, we're not actually feeding the cow. We're feeding the microbial population. We feed them with energy and nitrogen so the microbial population can multiply. This then is flushed out of the rumen then as microbial protein, along with any bypass. This is then available as metabolisable protein in the small intestine and is available to be absorbed as amino acids. As travelling, I wanted to visit high-input dairies to fully grazed herds. I wanted to meet with nutritionists, with consultants, and also visit research institutions along the way. As I visited Lincoln University in New Zealand, I met with Dr. Jim Gibbs. He gave me his interpretation of nitrogen efficiency. The amount of nitrogen utilised is constant, regardless of the nitrogen we feed. Changes to the diet won't increase how much nitrogen the cow uses, but a reduction in nitrogen intake will increase utilisation. This made it clear to me that the key to increasing nitrogen efficiency was to reduce the amount of protein we fed. However, I was intrigued to find out if we could capture more of that nitrogen we fed the animal and increase productivity. In the UK, we can grow grass as good, if not better, than anywhere else in the world. We have the climate and the natural resources to grow grass cheaply and efficiently. Grass tissue, when harvested, either grazed or when cut at the right time for conserved silage, is very high in nitrogen. But as we look at a rumen which is fed a high grass or grass-based diet, it is very unbalanced, with too much nitrogen, and we are limited in the amount of carbohydrates we can feed, mainly because grass is associated with low fibre, and also, as we conserve it, it increases acid load with high lactic acid. This reduces the amount of microbial protein that we can produce, increasing the ammonia or nitrogen loss from the rumen. Ammonia is toxic to the cow, so it's taken to the liver and converted into urea, where it is excreted. We need to increase this microbial protein production. This by increasing the carbohydrates within the diet, increasing microbial protein, and reducing this loss of ammonia. This took me to North America, visiting Wisconsin, New York State, and Ontario. Here, cows are fed on low nitrogen diets, which are high in carbohydrates, mainly based on maize silage. Cows here were producing 40 to 45 litres a cow, being very productive and efficient. Maize silage would be a great fit into our diets. However, our climate, growing conditions, and environmental concerns limit maize production in the UK. We need to rely on wheat as our main starch source, but it's commonly seen to increase acid load within the rumen. However, I saw firsthand in Victoria, Australia, cows being fed 8 kilos of wheat per day with no negative effects on rumen health, so it can be done. During my time at Cornell University, I met with Professor Mike van Amberg, and he told me we need to understand NDF, neutral detergent fibre, before attempting to feed the cow. Here, I became more familiar with their nutrition model, the CNCPS, or the Cornell Net Carbohydrate and Protein System. They had developed here new NDF analytics that would be built into their nutrition model, which broke NDF down into 3 further pools: fast pool, slow pool, and U, or undigestible NDF. If we are able to balance the fibre within our diet far better, we can then increase the amount of carbohydrates we feed an animal, being able to capture more of that nitrogen. I met with Michael Dineen, a PhD student at Cornell and a researcher at Chegas Clonakilty over in Ireland. Mike showed ongoing research on understanding NDF digestibility of perennial ryegrass and showed how rapidly degradable our grasses and grass silages are. Our US counterparts being very envious of our forages and don't understand why we can't increase production. This shows the potential our grasses have, and we need to understand our fibre to understand it. Beyond the rumen, in the small intestine, the cow absorbs amino acids. However, as I discussed with Mike Dineen and Ryan Higgs from New Zealand, even on grass-based diets high in protein, we are still restricting metabolisable protein and limiting in amino acids, these possibly being methionine and lysine. On grass-based diets, we do not need to supplement more nitrogen. However, in some circumstances, supplementing bypass or specific amino acids may increase production. In the Netherlands, I saw firsthand how legislation had affected the dairy industry. Now they target higher efficiency by increasing production per cow. This is great. They need to capture the nutrients that they grow on the farm and produce this into milk, reducing the dry matter they buy in onto the farm. I was expecting to find solely grass-based dairies in New Zealand. However, with land high value and high farm debt, farms were looking to increase production of milk per hectare. Although this was done through buying some dry matter in the forms of concentrates in, they looked to increase dry matter yields per hectare by growing maize and fodder beet. these also having the bonus of being low nitrogen crops. This made me look at whole farm efficiency. Land is our biggest asset. However, many of the high input dairies are too focused on yield and purchasing more dry matter onto farm to increase this yield. The waste then produced off them cows is then spread onto a restricted area, affecting soil biology and restricting dry matter yields per hectare. We need to look at increasing these dry matter yields before purchasing more dry matter onto farm. As I looked at whole farm efficiency, I wanted to look at feed efficiency. This led me to look at the cow we have in the UK. A large cow based on US genetics with a high maintenance cost. As I travelled to Green Bay, Wisconsin, I came across a herd with two groups which differed genetically. The crossbred herd with a third influence of Jersey versus a purebred Holstein herd. Although the Holstein herd produced more milk, they both produced equal amounts of milk solids. However, the crossbred cows did this off 2.5 kilos less dry matter. This, at today's price of dry matter, would be a saving of nearly £18,000 over 100 cows over 12 months. The bonus as well, the crossbred cows were also 3% more nitrogen efficient. So can we look at breeding a cow better suited to our diets in the UK, with a lower maintenance cost and higher milk solid production, which the milk processor requires? After my study tour, I have been driving protein inputs down on the farm at home, currently feeding a 15.8% crude protein diet, and as of yesterday, we were 31% nitrogen efficient. I have been using the CNCPS model to do nutrition on farm for Wednesday. We have been reducing protein within diets, having very positive results, increasing performance and reducing diet cost per litre by between 0.3 and 0.5 pence. Myself, with Wednesday, have also been a part of the Cow Efficiency Project, an EU-funded project to improve nitrogen use efficiency on farm, partnered with European universities and Cornell. As a proud dairy producer, I am determined to increase public perception of our industry whilst driving profitability on farm. The key messages from my report are the UK needs to be proactive in reducing ammonia emissions. I've spoken about the tools that we have available, and we can achieve this by feeding lower protein diets. This will give us a more profitable and sustainable dairy industry. Ladies and gentlemen, thank you very much for listening. Diolch yn fawr iawn.